Hi, my name is Dhiraj Khanal. I'm a lead engineer at InstaLILY, and today I'm going to talk about fine-tuning. Yeah, so usually when I talk about fine-tuning, I like to begin with the most basic element that powers it, the algorithm itself, transformers. Transformer as an architecture are algorithms that are neural networks. They are the fundamental thing that powers any LLM. You know what LLM is in its very raw form is a next word predictor that is trained on the internet data. And internet data includes all of the data that you can think about, from Reddit, from academic papers, from your favorite writing, love stories. It can be anything. You might ask, how useful is this quality of next word prediction? Turns out it's very, very useful. For example, Elias Oskever has this beautiful analogy where imagine you are reading a detective story. It goes through all of the plots, talks about all the events and all of the happenings. And at the end, the last sentence is, the murderer is dash. To accurately predict that next word, you actually have to understand all of the story. In some sense, LLM have this story or the world model kind of generalized. That's why they are such a beautiful machine that can be used for so many other things. However, the LLMs who are familiar with chatbots and things like that are not just next word predictor. They are assistant model that we can use for so many useful tasks. So how did it go from next word prediction to being a chat assistant? There's a lot of process goes that in between that. One of the primary process is by using supervised training. For that, you'd need to actually collect demonstration data set, which just means question answer pairs, and then you do supervised fine tuning on top of it. So now we can go from next word prediction to actually LLM being a chat assistant that you can actually ask a question and expect an answer. However, they are not that good yet. You do more data collection and you rank different data input-output pairs as well. And now you can actually perform different types of policy optimizations like TPO, which is called direct preference optimization, or PPO, which is called proximal policy optimization, to enhance the quality of this data set. And this process was excelled, of course, by OpenAI, and in other words is also known as RLHF. RL here, it stands for the reinforcement learning part of things, and HF stands for, it's actually coming from humans themselves. You know, this is the process approximately which makes an LLM a generalist assistant that, of course, knows about the world, like you'd know about the detective story, and also can approximately guess who the culprit was, also help you out in other tasks. Next, I suppose, just to complete the story is, how do we go from generalist assistant to a specialized assistant? Just to remind you, generalist assistant, the big models are multiple trillion parameter long. So they are very, very big. Usually dealing with this model as a post-training process becomes a very, very expensive thing in itself. So whenever you go from generalist to a specialized model, you don't have to do something called full fine-tuning. You can do parameter efficient fine-tuning, aka known as PEFT. And one of the most popular efficient parameter fine-tuning is LoRA, by the name of low ranking adaptation. What LoRA does is helps you kind of only train a part of low ranking matrices and not the whole thing, so that at the end you end up getting this similar effect as full fine tuning, but it's also way more handleable and sizable to do fine tuning on. So this is a very popular technique now used by many labs to make generalist assistant to specialized assistant. How do you get the data to make it a specialized assistant? You can ask a human expert in that domain, get that data that way, or you can do various type of reinforcement learning policies to also engineer the data as well. One of the popular example recently that happened was International Math Olympiad. LLM was able to get a gold medal solving 5 out of 6 questions in a very specific non-trained data, which is also shows how powerful they can actually be. This is also can be used, for example, by healthcare to kind of answer healthcare problems, or used by us at InstaLILY, for example, for part prediction, a specialized model for that, or data extraction. The final puzzle here is to do with reasoning models, which of course have been popularized very recently as well. Turns out, when you think an answer, it's really useful. It also increases the accuracy by a sizable figure. So nowadays, the inference time spending your compute on the inference time rather than the training time has also become very popular, which we have utilized at our company as well very much. Yeah, you can use very similar technique to kind of make that process happen as well. And it has proved really, really useful in especially sophisticated reasoning kind of tasks. All in all, just to kind of, summarize all of this, fine tuning can be thought of. So there is this meme that got popular at end of 2023 based on this monster called Sagoth. The picture essentially is there is this big monster, which is your internet pre-trained transformer that we talked about. And then there's a face, not a smiley face, but just a face, maybe a little angry one, maybe no emotion. This is what you get out of your demonstration data set. Now the LLM becomes a little more, friendly, chat assistancy. At the end of it, there's a smiley face. This is the RLHF portion of it. This is the supervised fine-tuning portion of it. And this is the unsupervised fine-tuning portion of it. This is how it kind of works. This is what we really interact with. This is what we don't see. So it's a pretty big thing, kind of distilled into a very small thing. At InstaLILY, we have really specialized this portion of the training example where we can go from generalist agent to specialized agent using various reinforcement learning and fine-tuning policies. They really do a very good job for domain-specific tasks. What I mean by that is a generalist agent can only become specialized when you have actually a proper training and a domain knowledge about what the problem that you're trying to solve. So this step, for us has involved talking to a lot of experts in a domain or a field and to get the question answer pairs and also get a lot of human feedback. So what we have actually specialized in is putting human feedback back into the model in production. If you are able to do this in production, that means your model can become better with human feedback. So a model that is deployed is not static anymore. It's actually learning from the signal as it is inferring. There are other things as well here. For example, things like LLM as a judge that you can incorporate, but you have to be extremely careful on how to implement it. So yeah, this was a quick crash course on fine-tuning and how everything kind of works from transformer all the way to the reasoning models. Thank you for watching. Does it work? I mean, I don't know how it sounds.